Good afternoon all. In the last class we have seen Hebbian based learning group, which is based on the Hebb's characteristics and Hebbian synopsis. In today's session we will see another type of learning method, that is memory based learning group. Mathematical expressions are as follows for this memory based learning rule. In this rule, all the past experience are explicitly stored in a large memory of correctly classified input-output examples. So here that classification is important. So correctly classified input-output example. Let us take the expressions. So the xi di over I is equal to 1 to n. Then close bracket xi comma di, which is from I is equal to 1 to n, where I is equal to 1 to n. So here xi is the input vector and di is the corresponding desired response. That means each input vector has one corresponding desired response. x1 has the corresponding desired response as d1, xn has the corresponding desired response as dn, and so on, right? So based on this memory, for example, based on this expression, each vector input vector is having some desired response. Based on that, by using the learning method, we need to identify the correct classification. For example, the binary pattern classification, if you see, there are two classes. Let us name those classes as E1 and E2. E1 is one classifier or one class, and E2 is another classifier and another class. For DI is equal to 0 for class E1 and DI is equal to 1 for class E2. That means all zeros belongs to the E1, all ones belongs to the E2 class. So all zeros belongs to the E1 class, all ones belongs to the E2 class. Class means let it be group. The group of zeros belongs to the E1, the group of ones belongs to the E2. When the classification of a test vector x test is required, so you want to find out that x test belongs to in which group. The algorithm responds by retrieving and analyzing the training data. Earlier, if you provide some training data, based on that data, so the x test, that x test may be either 0 or 1, but the corresponding x test value belongs to which group. That need to be found out by analyzing the training data in the local neighborhood of the x test. That means in the local neighborhood we need to decide, and in that the x test need to be identified whether it belongs to which classifier. Generally, all the memory based learning algorithms involve two essential ingredients. One is criterion. What is the criteria we are using for defining that local neighborhood of the x test? Local neighborhood means if you want to find out x test, that value belongs to which classifier, means around that area there is a local neighborhood of the x test. Second one is learning rule applied to training examples in local neighborhood of the x test. To find out that x test, which learning rule we are applying, even though it is memory based learning rule, how to identify that x test, based on what? So that we'll see in the further slides. So this is a learning rule. Nearest neighbor rule. Nearest neighbor rule means the local neighborhood is defined as the training example that lies in the immediate neighborhood of the test vector x test. If it is x test neighborhood, you can identify that x test is belongs to which classifier. That will be identified by using the distance. The distance will be found out by using the second line, like the vector xn dash is belongs to the x1, x2 and so on, x test and so on, xn. So this xn dash, that identified xn dash is, let us take this as example, xn dash is belongs to x1 to xn. Among them, x test is also one of the value. Then that is to be the nearest neighborhood of the x test. That x test is what we are trying to get. But in that, if you don't find that x test, what is the nearby that x test? Let us take that xn dash is near to the x test. But to find out that x test, you should find out that xn dash, which is near to that x test. So now that's why that xn dash, we are assuming that xn dash is belongs to this 1 to n number of samples. In that, x test is also one of the value. So to find out that the minimum distance, minimum d is nothing but distance, minimum d of xi comma x test, where I is equal to 1 to n, is equal to d of xn dash comma x test. What we do is, we will substitute I is equal to 1 to n and we'll calculate the distance. We'll try to find out the distance between the xi comma x test. For I is equal to 1, x1 distance, x1 to x test distance, x2 to x test distance, x3 to x test distance, and so on, xn dash to x test distance, and so on, xn to x test distance. So for each two values, from x1 to xn versus x test, will get one distance. The distance is nothing but, here minimum distance only we are giving at the out of the right side of that equal, right? That's why the minimum distance is equal to d of xn dash comma x test. That means the distance between the xn dash and x test is the minimum distance, that is indicated with d of xn dash comma x test, where d of xi comma x test is the Euclidean distance of the xi and x test. So that is a normal distance, generally we will call it as Euclidean distance of the xi and x test. So what are the problems in finding general distance, like what we have followed? The nearest neighborhood rule. So here Covert and Hart in 1967, they have studied formally the nearest neighborhood rule, and based on two assumptions. One is the classified examples are independently and identically distributed. If that classified examples are independently and identically distributed, means that is not a problem. And also the assumption is the sample size n is infinitely large. So infinitely large, and those are identically and independently distributed. Under these assumptions, the minimum probability of the error over all the decision rules. For all the decision rules, there is a probability of getting minimum error. There is a problem here by using this nearest neighborhood rule. Because sample size is n, that n dash, which is the actual point what we were find and which is near to the X test. But to search that, we are assuming that that is infinitely large group we are searching, and all are independently and identically distributed. Let us take to overcome this problem. The researchers went with the k nearest neighborhood classifier. So what is k here? Earlier nearest neighborhood classifier that has been added with k nearest neighborhood classifier. First, you identify the k classified patterns that lies nearest to the test vector X test for some larger k. Instead of taking the infinite classified group, take some subgroup, that is k group, which falls, that X test also falls in that subgroup or k group. So that's why the k classified patterns that lies near to the X test vector. Sorry, k is nothing but some integer value k. So assign that X test to that class that is the most frequently repeated in the k nearest neighbor to that X test. Use a majority vote for the classification means to decide that k group, majorly what are repeating. For example, X test, let us assume X test is 1. Then to identify that k group, or X test is near to the 1. Then to identify that k group, we try to decide that k group which will falls in that ones only. If it is close to the 0 means which will falls that k group in the zeros only. Even if both are combining also, zeros and ones are combining, if it is not uniformly distributed, then in that case, if your X test is near to the 1 means, then you should choose that which are more ones in that near to that X test value. That region we have to select. That decides by the training training algorithm. So based on the past memory, it will decide. We have to give that 2 years training data or 1 year training data. Based on that, it will select. Let us take this example for better understanding the memory based learning rule. Let us take for k is equal to 3. For k is equal to 3 means 3 group of set. 3 group will be combined into one classifier. An outlier is an observation that is improbably large for a nominal model of interest. Let us take for k is equal to 3 means it is generally that group we can take more number, but here a small group, that is k is equal to 3 only we have selected. We are thinking that outlier is false in this k is equal to 3 group. Here D is the test point which is near to the 0. The outlier, which is nothing but the distance between the 0 to the corresponding X test vector. So the group of nearest neighbors are considered for classification and finalize the most neighbors classified. Here D is classified as 1 but not 0. So simply for just what are that lines means, here I have taken k is equal to 3. K is equal to 3 means I have to consider 3 points as a group and I have to test that. I have to find out that X test. To do that one, so after finding out, after taking that group 0, 1, 1, this is random based on the memory only. It will choose that k is equal to 3 as group of 0, 1, 1. If you go for that group, then how that distance will be calculated, that's what here I am telling. So the how to identify that exact 0, 1, 1 as group means that is based on the past memory only. It can identify. Even to identify that k is equal to 3 group also, it will take number of iterations. So here k is equal to 3 means 3 set of values are forming one group. In that x test, let us assume that at d place we think that x test value is there. So what are the majority values in this group? 1 is a majority values because 2 ones are there, 1 0 is there. And what is the minimum distance here? Let us take the minimum distance is to the x test if it is 0 also. Say d at d place, let us assume that x test vector is there. But as per the definition, if x test vector is near to the 0 means the normal near neighborhood rule, that x test also it is 0 only. But that is wrong classification. In which group it is there? Overall all ones are there, right? In that ones group it false means it should be, it may be, most probably it should be 1 only, not 0. So that's why even though that x test is near to that 0, but more number of values in that group is 1 in that circle. 2 ones are there, 1 0 is there. If x test is near to the 0 also, it may not be the correct one. That may be the probability, the chances to be 0 is less and chances to be 1 is more, because it falls in the ones category. So that's what the advantage of this k nearest neighborhood rule. So here again I am repeating that distance between the x test vector and 0 value is minimum. Even though if it is minimum, in that k is equal to 3 group of circle, what are the most values? The value of that other vectors is 1. 2 ones are there, 1 0 is there. Here I have taken only sample small size, but let us take if it is some 20 size number, in that only 1 0 is there, but remaining all values are ones only. Even though if your x test vector is near to the 0, what is the probability of that x test value? Means it is equal to 1 only, because in the selected group 0 only 1 value, but remaining 19 values are 1 only. So there is a good chance for that x test value equal to the 1. That's what I would like to convey here. So in the ones group directly we can say that it is belongs to 1, or it belongs to 0 if it is 0 group means. But if it is combined, non-uniformly distributed means, then you have to go for that majority values. Your x test value is equal to the majority values. Here majority values are 1 in that circle. That's why your k nearest neighborhood rule will decide based on the majority values. Okay. So this is all about the memory based learning rule. Thank you.